All right, polynomial limits at infinity should be related and familiar as far as the power rules. So if you have ax to the end behavior of the graph is what we're looking at here. So you really have four different pieces. You have f of x, ax when x is to the even power. When you have a positive a, that end behavior of the polynomial, no matter what happens, always is going to start up and end up. And the reason that happens is it does not matter what a is. When you go ahead and put in either a positive value here and then raise it to an even power, or a negative and raise it to an even power, your output is always going to be positive. Now, on the opposite note with that, if you have f of x is equal to negative a and then x is to an even power, the whole thing flips over. So it's going to be start down and end down, no matter what happens in the middle there. So, and again, the same reason is true if you have a negative a on the outside. It doesn't matter that the graph will always end being negative. Now, what do the limits of that look like? What that means is if you have the limit as x approaches infinity of 3x to the fourth plus 10x plus 7, because this is to an even power and a is positive, this graph will approach a positive infinity. If you have the limit as x approaches infinity of negative 8x squared plus 7 plus 1 over x, again, the most important portion of this is this negative 8x squared. This one, what happens here is this 7 doesn't matter relatively. 1 over x, that approaches 0. But negative 8 times any number that's very, very large, being squared, that negative out front is the key indicator, and this is going to approach negative infinity. Going back to our rules, if a is to an odd power, if you have positive a, what this means is the graph will end going up. So it has to start in the opposite direction, so it's going to start down and end up. If f of x had a negative a and x was odd, it does the same exact thing. It means, again, there's a negative in front of that. That means the graph is going to end going down with however many turns inside here. So using those from your pre-calc or college algebra or algebra 2, let's go ahead and take a look at the limit as x approaches infinity of negative 5x to the 7th plus 10 And in this case, I want to look at both sides. What about the limit as x approaches negative infinity? Same function, negative 5x to the 7th plus 10. All right, so this again leads to positive and negative down behavior. So what do I have here? I have a negative out front, so that means the graph is going to end going down like this right here. So at positive infinity, this limit approaches negative infinity. On the opposite side here, this asks, where does the graph start? Or where is the graph on the left side? And this graph starts up here. So this would equal a positive infinity.